Hello friends, in this video we are going to discuss the previous year GATE question number 66. This question is from GATE 2017 examination. So let us read the question. A three-phase voltage source inverter is supplied from a 600 volt DC source as shown in the figure for a star connected resistive load of 20 ohm per phase. The load power for 120-degree device conduction in kilowatt is, okay. So input voltage is given, it is a 600 volt, okay. So we can write EDC is equal to 600 volt. Conduction is 120-degree conduction mode and R is 20 ohm. R is equal to 20 ohm, okay. And our task is to find the load power, okay. So if you check the load power, we are having direct expression, okay, or we are having the per phase voltage RMS value, that expression also, okay. So what is the VPH RMS value of per phase voltage? Yes, it is equal to EDC by root 6 we are having, okay. So we can write it as 600 divided by root 6, so is equal to 600 by root 6, 600 divided by root 6, so it is equal to 245 volt, 245 volt, okay. So this is V per phase RMS value of load voltage we are having, okay. VPH RMS, or you can write V0 RMS value, right. So next, load power, therefore P is equal to load power is equal to, yes, it is a 3 into VPH RMS value of load voltage per phase square divided by R. So this can be written as 3 into, this is 245 square, right, 245 square divided by R is equal to 20, okay. R is equal to 20, right. So from this we can write it is equal to, yes, this is equal to 245 square divided by 20 into 3, so it is a 9.003 kilowatt, okay. 9.003 kilowatt, okay. So power is equal to roughly 9 kilowatt, okay. It is a 9 kilowatt. Is clear? So this is about question number 66. In the next video we are going to discuss the question number 67. Thank you.